Doctoria.
Good morning, class. This is another day that the Lord has made. We shall rejoice and be glad in it. Welcome to class this morning. Today we shall be having PHY 104 tutorials. And before that, I would like to go back to one of the lectures. The first lectures where we had about 6 questions or 6 worked examples. And I told you that at the end of the lectures, we are going to look at those questions again. So although I have compiled the questions, but let me go and share that file. Sorry, 1 minute. Okay, this is the one I'm talking about. When we had these lectures, Olatunde Abisola, you are disturbing. Please mute yourself. When we had these lectures, we had a number of worked examples or questions we didn't really work out. This is number 1. We had number 2. We had number 3. We had number 4. We had number 5. We had number 6 and number 7. This was number 7. So today I have compiled all these questions in one file, and we are going to solve them together. So I'm going to be sharing the file where I have compiled them, and this is it. So this is the worked example 1 that we're going to look at. I don't know if a number of you have succeeded in trying it out, but before we go on, let me see if my colleague is here so that I can make him a co-host, so that he can help me to be muting some of you that are disturbing. Just a moment. Not yet. Okay, I'll check again later. In any case, let's go on. So this is like worked example 1. This is question 1, which says, excuse me, let me pick my highlights. A 55 loop circular coil has a radius of 4 centimeters. It is oriented so that the field lines of a magnetic field are normal to the area of the coil. The magnetic field is varied so that B increases from 0.20 Tesla to 0.45 Tesla in 2 milliseconds. Find the average induced EMF in the coil. Find the average induced EMF in the coil. So you get your exercise book, you get your notebook and your biro, and let's solve this together. In solving this, go to the slide. Oops. And this is what we are asked. You remember this formula? Okay, so the magnetic flux is given by the magnetic field times the area, and the change in flux is given by this formula, final magnetic field. Oh, who is disturbing us now? Please mute yourself, everybody. Mute yourself. Mute yourself, everybody. So magnetic flux is given by this equation, and change in magnetic flux is given by this, the final magnetic field minus area, the same area, minus the initial times area, the final flux times the initial flux. So we are given in the equation, we are given 0.45 as the final, as the final magnetic field, BF, this is BI. If you evaluate this, you get 0.25 Tesla pi r squared. The area of the coil is pi r squared. If you evaluate this further, remember we had it in 4 centimeters squared. 4 centimeters squared. So you convert it to meter and you square it. So that's the radius. The radius is 4 centimeters. But if you square it like pi r squared, oops. So, and pi is 3.14. So 0.25 times 3.114 times radius square, r squared. If you evaluate that, you should get 0.001256 Weber for each loop of the coil, So what are you asked to find? You're asked to find the induced EMF. If you go back to that question, you're asked to find the average induced EMF in the coil. Find the average, take note of the word average. Find the average induced EMF in the coil. So we go back to that solution. So this is the average EMF in the coil is given by this equation. So average EMF is equal to, the number of turns is 50. Then change in flux delta phi is given by this solution we got here, divided by change in time. And we are told that the change in time was 2 milliseconds. Milli is 10 raised to power minus 3. So 2 times 10 raised to power minus 3 seconds. Because all your units have to be SI. So if you evaluate that, you get 31.4 volts. 31.4 volts. So we don't have too much time today because we got to end the class 8:45. So let's go back to the second, let's go to the second question. The second question says, calculate the induced EMF in a 150 centimeter squared circular coil having 100 turns when the field strength B, when the field strength B passing through the coil changes from 0.0 to 0.001 Tesla in 0.1 second at a constant rate. Calculate the induced EMF. So how do we do that? Let's go to the solution here. It's number 2. You use Faraday's law. Using Faraday's law, given by this equation, we have 150 is not average, it's induced EMF this time around. In this case, it was average EMF we were asked to calculate. So 150 times 10 raised to power minus 4. If you convert that to meters squared, then times 400 tons times change in flux all over time. Let's see the question again. Calculate the induced EMF in a 150 centimeter squared circular coil having 100 tons. When the field strength passing through it changes from this to this, that's the change in magnetic field at a constant time. So evaluating that, we have this equation. Using Faraday's law, if you evaluate this properly, you should be able to get minus 0.015 volts. Minus 0.015 volts. So we go on to the third one, the third example. Third example says, in a motor, a conductor. Okay, before we go on, let me check if Dr. Shakwande is here so that I can make him a co-host. Okay. All right. The question, this is question 3 or example 3 we had during the first lecture, but we couldn't work it out. For those of you just joining the class, we've done examples 1 and 2. This is example 3. In a motor, a conductor 120 millimeters. Always take note of the units involved and convert to SI units. In a motor, a conductor 120 millimeters long carries a current of 22 amperes. If it lies perpendicular to a uniform magnetic field of 1.4 Tesla, what is the force on the conductor? What is the force on the conductor? That's question 1. What torque is produced if the conductor is 50 millimeters from the axis? That's the distance from the axis of the motor and parallel to it, and the field points from the axis to the wire. I'll take the question again. Meanwhile, your lecture notes, the slides have already been uploaded, so you can check later if you have not checked. All the slides for all my lectures have been uploaded, except today's own. So after today's class, this question, I don't need to upload these questions because you already have them in the slides. So write down the solutions as we go on, because this slide will not be uploaded. You already have the questions. What I did was to just compile all the questions together and we are trying to solve them together now. That's why I said at the beginning that you should have your exercise books, your notebooks by your side and your biro, and I expect that you are writing the solutions. Okay, so this is the third question we are going to solve. It says, again, I'll go through it again. In a motor, a conductor 120 millimeters long carries a current 2 amperes if it lies perpendicular to a uniform magnetic field of 1.4 Tesla. What is the force on the conductor? That's the first question. What torque is produced if the conductor is 50 millimeters from the axis of the motor and parallel to it, and the field points from the axis to the wire? So we go and look at the solution. So force is equal to current times length. Sorry, this should be small letter. It depends. But this L stands for the length, the magnetic field. So we are given the current to be 2 amperes, the length 120 millimeters, but you have to convert to meters. And this is the magnetic field in Tesla. So the force is equal to 2 times this, 0.120 times 1.4. If you evaluate this correctly, you should be able to get an answer which is equal to 0.336 newtons. 0.336 newtons. So for the torque, we have the distance times the F, and half times F gives us, it says 50 millimeters. If you convert 50 millimeters to meters, you have 0.05 meters. And the force calculated here, and the force calculated here, it gives us this 0.0168 Newton meter. The unit of torque is Newton meter. Newton meter. So it's the same thing as 16.8 times 10 raised to 3 minus 3 Newton meter. So this is the. So let's go on back to question 4. Was example 4, first lecture, says a motor running at full load on a 180 volts line develops a back EMF of 107 volts and draws a current of 6 amperes through the armature. What is the mechanical power output of the motor? Disregarding frictional losses. What is the armature resistance? So there are 2 questions here. The mechanical power output of the motor and the armature resistance. So let's go and find out the formula to use in this case. Let's epsilon naught. Somebody should mute himself. Adegbenro Aderonke Ganiyat. What is wrong with you? Olagunju Tohid. Please come and take over the tutorial class. Mute yourself. Olagunju Tohid. Olawale. Olagunju Tohid Olawale. Matric number 222963. Mute yourself. Thank you. So as I was saying before the rude interruption, question 4 is solved this way. Let epsilon, you had better be serious. I don't want anyone to provoke. So let epsilon naught be the back EMF developed in the motor. So the power out, the mechanical power output is given by this formula or by this equation. The back EMF times the current, armature current. So the back EMF is 107, the armature current is 6. 107 times 6 gives us 642 watts. You can evaluate that now. That's why I said be writing because this slide will not be uploaded. You already have the questions in your first slides, during your first. So evaluate it, you should get this. So for the resistance, we have VT is equal to the back EMF plus the current times the armature resistance. So this is VT is the voltage. Sorry, go back to the question. Yeah. The motor running at full load of 118 voltage line develops a back EMF of this and draws a current of that. Okay, I've seen what I mean. So for the resistance, we are using this formula. So this is the current. If you make IRA the subject of the formula, the line voltage minus the back EMF over RA, the armature resistance times current. So make RA the subject of the formula. This is just the process. If you make RA the subject of the formula, what you have is 118 minus 107 will give us 11. 11 over 6 will give us 1.83 ohms. 1.83 ohms. If you evaluate this correctly, you get 1.83 ohms. So this is the armature resistance and this is the power. Oops, sorry. That's the mechanical power output. So we go on to the next question. This question says an AC generator. I gave you the answer the other day, the time we had this class. I gave you the answer and some of you confirmed it immediately by sending me messages. They confirmed that the answer was correct, but since it's a tutorial class, let's just have a look at it again. An AC generator produces, 1 minute. An AC generator produces an output voltage epsilon equal to 150 sine 367 times time volts, where T is in seconds. What is the frequency of the AC voltage? So we using this formula, we have 367 T equals to 2 pi FT. And there's a hint here or a note that says a sine curve plotted as a function of time is not different from a cosine curve except for the location of T equals to 0. So equating this to this, from which we find the frequency. How do we find the frequency? You make F the subject of the formula here. Okay, I have it. Let's go and check. I think this is it. Okay, equating 367 T to 2 pi FT and making F the subject of the formula. You have 367 T over 2 pi FT. T and T cancels out, and you have 367 over 2 pi. Pi is 3.14. So 2 times 3.14, whatever it is, you write it there, then you evaluate this, you should get this. And quite a number of students got it correctly when we had the class. So in case you didn't get it correctly, this is the way to go. So we go and take this other question. This one says, how fast must a 1000 loop coil, each with 29 centimeters squared area, turn in the Earth's magnetic field of 0.7 Gauss to generate a voltage that has a maximum value, that is an amplitude of 0.50 volts. And the hint we were given then is that we assume the coil's axis to be oriented in the field so as to give maximum flux change when rotated. I knew the second class, we went through the different orientations of magnetic fields and currents, and we arrived at different equations for the magnetic flux. So for this particular problem, it's going to be solved this way. This is number 6. Using the hint you are given, using this hint, epsilon equals to 2 pi n number of turns, area, magnetic field, which is this F frequency cos 2 pi ft. Because cos 2 pi ft has a maximum value of 1, the amplitude of the voltage is equal to epsilon equals to 2 pi NABF. Because if cos 2 pi f is 1, then epsilon is equal to 2 pi NABF. So if B is equal to 7.0 times 10 raised to the power minus 5 Tesla, you make F the subject of the formula here. You first find the frequency, then you find the angular velocity, because it's saying how fast must it move. So let's take a look at the solution together. So if you make F frequency the subject of the formula, like I said, you have this combination, okay? This is epsilon. That's the that's the voltage, maximum voltage. Maximum voltage equals to 0.0 volts, then 2 pi. So 0.05 over 2 pi NAB. That will give you the frequency. So that's what we have done here. So 2 pi and 10 raised to the power 3 times 2.9, you evaluate this in meters. If you make 2.9, 29 to meters, it gives you this. It's either 29 times 10 raised to the power minus 4 or 2.9 times 10 raised to the power minus 3 times B, 7.0 times 10 raised to the power minus 5. So evaluating that and making F the subject of the formula, you get this for the frequency. And you know that omega is equal to 2 pi F. That's the angular velocity. And if you evaluate that, you get 2463 radians per second. Radians per second. So let's say about the last. For a step-up transformer is used on a 120 volts line to furnish 1,800 volts. The primary has 100 tons. How many tons are on the secondary? I gave you the solution as 1,500. And some students confirmed this by sending messages, but some did not. So in case you did not, and I told you that this is the equation or formula you require to solve this problem, okay? So let's see how it goes. Here we have Vs over Vp equals to Ns over Np. And we have the Vs is 1,800 and Vp is 120, Np is 100, and we are asked to find the number of tons in the secondary. So you make Ns the subject of the formula. If you make that the subject of the formula, you have this combination, and if you evaluate that, you get this as the answer. You get this as the answer. Let me see if my colleague is on now. Otherwise, I'll just give some. All right. Okay. Dr. Shakwade, you're welcome. Okay, we'll give an announcement at the end. I've not finished. Let me just summarize what I have to say. You know, an important aspect of physics is problem solving. So in general, this involves the application of physical principles and equations to data So I said that an important aspect of physics is problem solving. In general, this involves the application of physical principles and equations to data from a particular situation in order to find some unknown or wanted quantities. Like you have seen in some of the tutorial questions, we have been able to apply some physical principles and equations to particular data that are given for particular in different situation or for particular situation, for a particular situation. So what do you do when you have a problem? Read the problem carefully and analyze it. Read the problem carefully and analyze it. Where appropriate, draw a diagram. Where appropriate, draw a diagram. Write down the given data. Write down the given data. Okay, you are given current, you are given back EMF, write them down and write down what is to be found. That will help a lot. Then determine which principle are applicable. Which equation is applicable to this question? Which principle is applicable to this question? You like, is it like we have here? Can say, is it this case, use Faraday's law? Is it Faraday's law? Is it Lenz's law? Is it force you are looking for? Is it an average induced EMF? You know, what is it that you are looking for? That will guide you. So you determine which principle or formula is applicable, then perform calculations with given data. Always remember to make your unit conversion. That's very important. A lot of students have missed it because of unit conversions. They always miss the right answer because of unit conversion. When something is in millimeter, centimeter, you must convert to meter before you continue your work. And then consider whether the results are reasonable. So this looks like where we are stopping today. And I would like to tell you that you'll be having your test on the 20th. I think you have PHY 104 continuous assessment test 2 on Wednesday, 20th of October. That should be next week, really. That should be next week. Yes, next week, Wednesday. And you will have PHY 105 continuous assessment test 2 on Thursday, 8 to 9 on Wednesday, 8 to 9 on Thursday. I don't know if Dr. Shakwande has any additional information or announcement to make. Dr. Shak. If there is none, that is the announcement for now. You'll be having your second. Okay.
Okay, dear. Good morning, madam. Thank you so much.
Good morning. How are you? Welcome.
The only announcement is about the second tier, which will be coming up next week. Physics 105 will be coming up next week, Wednesday. while Physics 104 will be coming up next week, Thursday. Both of them at 8 a.m. So that's all.
Sorry, is it 105 that will come first or 104?
Yes, 105 will come first because we have 105 on Wednesday.
Oh, okay, I see. Okay, because I told them.
Okay. On Thursday.
So 105 will come first on Wednesday, 8 o'clock, while 104 will come up on Thursday, 8 o'clock.
Yes.
Okay, I hope they have all had the announcement. I mean, it will also be pasted. I think it will be pasted in the department.
Yes, it will be on our notice boards in the department, and I will also announce it on the LMS page as well.
Oh, okay, that's fine. Thank you very much.
Thank you so much.
So today marks the end of PHY 104 lectures. There won't be lectures again until another section. So I wish you the very best in your forthcoming test and also in your exam. Remember that your continuous assessment test carries 40 marks. We carry 40 marks, and your exams will carry 60 marks. There will be 30 questions during your exams. There will be 10 questions to answer next week for your second CA. Yes, Jennifer. Well, in addition to all the announcements, hold on. In addition to all the announcements, our office numbers are written on the LMS pages. On the LMS page, rather. Our office address. Let me put it that way. Dr. Shakwande's office address is there. My office address is there. So in case you still want to clarify one or two things. And this particular time for which you should be able to see us is also written there on the LMS page. It's not that you come 9 a.m. in the morning and say, I want to see you. No, there is a particular time on that LMS page that you can see us physically, but you have to put in place all the NCDC COVID-19 protocols. Without that, you won't be attended to cover your nose and all that. So what does Jennifer has to tell us?
Good morning, ma.
Good morning.
Ma, I wanted to ask that for this second test, is it only your part that we are reading, or we are reading the mixture of Dr. Okunshade and your part together?
Sorry, it's Dr. Shakwande.
Okay, ma, sorry. Thank you, ma.
It's only my part. It's only the part I've taught you so far. And I think, Dr. Shakwande, Wisdom Bridge? Was there any question on Wisdom Bridge the last time?
I didn't tell you clearly, ma.
Was there any question on Wisdom Bridge the last test?
No, ma.
So we should add maybe one question on Wisdom Bridge.
Okay.
Wisdom Bridge. And what else?
We did not also add a potentiometer, Sama.
Okay, so one question on Wisdom Bridge, one question on potentiometer, then the remaining questions from what I have taught you so far, that's on electromagnetic.
One question on capacitors.
Oh, on capacitors?
Yes, if probably.
Probably, okay. Okay, probably.
Thank you very much, ma.
You're welcome. So you have one question from transformers, one or two, then one. From what I've taught you so far, anyway, the questions won't be difficult, don't worry. If you've been attending lectures and if you have attended today's tutorial class, and if you have been, I've given you a lot of problems and solutions. So if you have been practicing those problems and if you've been reading your lecture notes, you are not going to fail your test or your exams, both for me and myself and my colleague. So don't be afraid. Thank you. So please, let's You can, like I said, my office address is Block C, Room 5, Physics Department, Block C, Room 5. So I think that's all. Please don't come late to the test venue. Be there by 7:30 a.m. Be there by 7:30 a.m. both for the test and on the day of your exam. You have to be at your venue 30 minutes before. Don't come late. Don't oversleep. You are not going to be allowed to borrow. Bring your calculators. Bring your calculators. The venue where I invigilated test last time, TA test 1. You can't believe it. A student said he forgot his calculator. Don't forget your calculator. And everyone was busy with their own calculators. So all those things are very, very important. So what's Samuel? Samuel Anoluwapo. What is it? Okay, we'll end the class here. I wish you all the best once again.